All right, if we look at option D, we can see that vector B is being added to vector A, and that will give us the resultant of vector C. So for option D, we actually get vector A being added to vector B, and which gives us our resultant, which is vector C, which is still not what we're looking for, so D would be the right answer. All right, let's move on to question number 8 now. All right, so for question number 8, two forces act on an object as shown in the diagram. Which of the following best shows the resultant of these two forces? Now, when you're finding the resultant, all you're really doing is you're taking your two vectors, F1 and F2, and you're simply adding them together. So if I add them together, it's going to look like something like this. This is vector 1, and there's vector 2. And the resultant would be from the start to the finish, just like that. So that would be the resultant. And for this diagram, the resultant here is simply going to be noted as F1 plus F2. All right, and I believe the resultant right here going up in the northeast direction, that is probably C. C is the best answer there. Okay. All right, let's move on to question number 9. A boat shown below, so here's my boat, travels at 4.2 meters per second relative to the water. All right, so 4.2 meters per second, and the river is flowing at 2.8 meters per second. All right, so what angle must the boat head to reach the destination directly across the river? All right, so for this question, this is actually a simple vector question with a little bit of trigonometry. So I can call this vector 1, I can call this vector 2, and I'm simply going to add those two vectors. And when I do that, I get something like this. Here's my vector 1, which is 4.2 meters per second. The river is going at 2.8 meters per second, and the resultant is just simply going from the beginning to the end. And the question wants to know what this angle has to be. And we assume that this will be 90 degrees at that point. All right, so this is basically, in order to finish off this question, we need to use some basic trigonometry. So we can use, since this is a 90 degrees triangle, a right triangle, we can use SOHCAHTOA. And when we look at our angle, the 2.8 meters per second, that is my opposite side, and the 4.2 is my hypotenuse. So I'm looking for a trig function with an opposite and a hypotenuse, and that would be my sine function, opposite and hypotenuse. All right, so in order to finish this off, I would simply just write the mathematical expression here. So that would be sine of theta, which will equal to my opposite over hypotenuse. In this case, my opposite is 2.8. And my hypotenuse is 4.2. And in order to finish off this question, you would have to go right to your calculator. So in your calculator, this is what you would do. Turn the on button on. You push the on button on. It would be 2.8 divided by 4.2. You can hit the equal button. You get 0.666 repeating. And then in order to get the sine function, in order to get the angle, you would have to hit the second sign. And you can simply plug in your answer there. And you should get about 41.8 degrees. All right, so there's a basic Math 10 problem right there. All right, let's move on to question number 10 now. A few minutes after takeoff, a jet is heading due east. All right, so due east, there's a key word, with an airspeed of 300 kilometers an hour. If the wind is blowing at 60 kilometers an hour, which is heading at 40 degrees south of east, what is the jet's ground speed? Okay, so let's just draw some vectors here. I'm going due east. So that's going to be going at 300 kilometers an hour. And I'm also going at, sorry, the wind is also blowing at 60 kilometers an hour towards 40 degrees south of east. So if I draw my 4 quadrants, north, east, south, west, south of east is in this direction, and 40 degrees south of east, so 40 degrees would be right here. So if you had to draw a vector representation of 60 kilometers an hour going at 40 degrees south of east, this is what it would look like. This would be 60. All right, so what we're going to do is we're going to add those two vectors. So here's my first vector here in yellow, 300, and this is my other vector in green, the 40 degrees south of east. I'm going to simply add those two vectors. All right, so there is my first vector, which has a magnitude of 300 kilometers an hour, and here is my other vector, which is my this is going at 60 kilometers an hour. And I just want to say that this would be 40 degrees, and I'm looking for my resultant, which would be from start to finish. And whenever a plane is flying in one direction, and if you are going against an airspeed, the resultant is your plane's ground speed. So this is your ground speed right there. All right, so in order to solve this problem, we need to know this angle right here. All right, so let's break that down. If this was a right angle triangle, this would be 90 degrees. And if I want to find the remaining degrees here, that would be 50 degrees. 40 plus 50 would be 90. So the total angle here is simply going to be 140 degrees. So this will be 140 degrees. And that's simply 90 degrees plus 50 degrees. We're going to erase that now. All right, so there it is. I have a triangle. One side is 300, the other side is 60, and my known angle is 140 degrees, and I want to find the magnitude of this vector right there. All right, so basically we want to use, there is a rule from your Math 10 course, we want to use the cosine law. And let me just replace GS with the letter X, just for convenience. So in order to solve this problem using the cosine law, we would write down x squared equals to 300 squared plus 60 squared minus 2 times 300 times 60 times cos of the angle, which is 140 degrees. And generally the cosine law is, the general formula would be x squared equals to a squared plus b squared minus 2ab cos theta. And this formula is on your formula sheets. All right, let's solve this problem then. Let's go into my calculator, clear all that. Let's see, 300 squared plus 60 squared minus 2 times 300 times 60 times cos of the angle, which is 140 degrees. I'll get something like that. And then I take the square root of that, and I get 348.105. All right, so let's put that in. So if I solve for x here, I would get 348.105. All right, and that's very close to option, I guess option C. And don't forget our units, kilometers an hour. All right, so that concludes this video. I will finish question number 11 on the next video.